All right, number 22 from the quiz. All right, so it says a Ferris wheel is 100 feet in diameter. So you got this Ferris wheel, 100 feet in diameter. So if the diameter is 100 feet, then that means that the radius is half of that, so 50 feet, which means that that's 50 and this is 50. And then it says it rises to 105 feet off the ground, and so all the way to the ground is 105 feet. And so if the diameter is 100 feet, then that means that it's off the ground 5 feet right there. And then each revolution of the wheel takes 32 seconds. That's your period. The period is 32 seconds since it's the time it takes to go around once. And then express the height of the rider as a function of time if the rider's at the bottom. So at the bottom at t equals 0. All right, so at the bottom means if you're starting at the bottom here, you're going to use cosine and with a negative a value. Since you're starting at the bottom, your radius is going to be your a value. So a is how far, up and down you move. And then we can find b by doing the period is equal to 2 pi over b. And so 32 is equal to 2 pi over b. And solving for b, you would get 2 pi over 32, which will give you pi over 16. And then, the Ferris wheel is up off the ground. So your middle value is right here. That's the middle of the height of the rider, right? The rider will start here and it'll start traveling up and it'll get up to the highest point of 105 and then it'll come back down. But the middle is right here in the middle of the Ferris wheel, and so your D is the middle value. D is your middle, your shift up is your middle, and so that means that it's going to be 55. So your D is 55. All right, so putting all of that together, you want Y, because Y is your the height of the rider. Y is equal to negative 50 times cosine of B, so pi over 16, times T, and then plus the D value of 55. There's 22. I knew to use cosine because you're starting at the bottom. Starting at the bottom at t equals 0 means you need to use cosine with a negative a. If it was starting at the top, all the way at the top here, then it would be a cosine, but with a positive a. If they got in out the middle and there, then it would be sine. As if you remember the graphs of sine and cosine. Sine graph starts in the middle and then it'll go higher and come back to the middle and then go lower and then come back up to the middle, versus cosine with a positive a starts up high, comes down to the middle, goes lower than the middle, comes back up to the middle, and then goes back up high. That's with a positive a value, a positive cosine. Cosine with a negative a value would start down low, come up to the middle, go up even higher, come back to the middle, and then go back down low. And so since it started with down at the bottom, the rider got in at the bottom, then I knew it was a negative cosine. How do you graph number 2 from the quiz? Okay. So graphing 2 from the quiz. was y equals tangent of 2x minus pi minus 2. All right, so the first thing you want to do is factor out the 2. So you'd have an x minus pi over 2. So your a value is 1, your b value is 2, your c value is a positive pi over 2, and then your d value is a negative 2. If you remember, for tangent, c is your middle tick mark, and then you'll add and subtract the increment length from there, going left and right. Period for tangent is pi over b, and so that makes it a pi over 2. And then the increment length is the period divided by 4, which would be pi over 2 divided by 4, but that's the same thing as times 1 over 4. And so that's a pi over 8. And so when you graph this guy, you got womp, 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 womp. All right, I've got 5 tick marks. C is the middle one for tangent, so pi over 2 would be in the middle. And then you're going to subtract pi over 8 from it. So that would be what, 4 pi over 8. I rewrote pi over 2 for a common denominator. Minus pi over 8 would give me 3 pi over 8. It's going to be this guy. And then subtracting another pi over 8 would give you 2 pi over 8, which reduces to pi over 4. And then you want to add these guys also, so a pi over 2 plus pi over 8, which is that's a 4 pi over 8, would give you a 5 pi over 8. And then adding another pi over 8 would give you a 6 pi over 8, and that reduces to what? 2 goes into both, so a 3 pi over 4. All right, so I'm going to check the period, make sure I'm right. Over here, check period. So I would take the most right tick mark and subtract from it the most left one, which would give you a 2 pi over 4. That reduces to a pi over 2. Is that what we said the period would be? Yes. All right, so my tick marks are good. And then put it the x or the y-axis, it would be, all of these guys are positive, so your y-axis would be somewhere to the left of it. Here, I'm going to put a little x through it saying don't mark on there. And then, oh, I didn't draw it low enough. Okay, well, whatever. Your a is 1 and negative 1. All right, so tangent does asymptote, asymptote, middle here, up to 1, down to negative 1. And so tangent without the d value looks like that. But then we've got this shift down of 2 units. So that means I need to go doot, doot. So that's a negative 3. And so your asymptotes will still stay the same. Asymptotes with a shift up or down doesn't change, but these points will. So the negative 1 will go down to negative 3. The 0 in the middle will go down to negative 2. And this guy will be at a negative 1. And so your graph would have looked like that. And then you can walk away from these knowing you got them all correctly if you check a point. So if I check, let's go with 3 pi over 8. So y equals tangent of 2 times 3 pi over 8 minus pi minus 2. What would that be? 6 pi over 8, oh, no, 3 pi over 4 minus 4 pi over 4. That's a tangent of negative pi over 4, which is -1 minus 2. So did I say it was -3? Yes, it was. Check. I checked my point, and so everything works out perfect. So the quiz you didn't have to graph, but someone asked for me to graph it. How did I know where to put the asymptotes? Because that's tangent, a tangent graph. When you graph one period of tangent, y equals tangent of x, looks like bump, 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 doot, doot, and doot, doot. Asymptotes on the bookends. The regular graph is from -π/2 to +π/2, and then that's a 0, and at π/4 it's a 1, just from the values of tangent, right? Tangent's undefined at π/2 and -π/2. So that's the parent graph of tangent. And so we moved things with the A, B, and C and D, but yeah, I just knew that that's the way we graph it. All right. That was graphing that, and okay, so that number 14 on page 239. So it says a weight suspended from a spring is set into oscillating motion by compressing it to a point above 5.6 above its resting position and then releasing it. It takes 3 seconds for one cycle, and determine an equation that describes the position of the weight at time t equals seconds, letting 0 representing its rest position, and then graph the equation. All right, so your spring, if here's your spring, yeah, that looks great. What they did was they compressed it, if this is the resting position, right, then they compressed it above and then released it, and when they released it, then it went down and then back up and like that. So you're going to use a positive cosine because it got compressed above. So when it's starting the motion, it's starting up. It's like it's starting up here, and then it's going down and then up, and anyway. So it's a positive cosine. Your A value is 5.6. The period is 3 seconds, and that's 2 pi over B is equal to 3. So that means your B would be 2 pi over 3. Y equals 5.6 times cosine of 2 pi over 3 times t. And then graphing it. Wow. That's a funky graph, but it looks like that. Right here. It would be 3 seconds is your period, and so this would be 1.5 and then 0.75 and then 2.25, and then you're going up to 5.6 and down to negative 5.6. You would start here and then there and then there and there and there. There's the graph. All right. All right, do number 3 from the quiz. All right, so I gave you this graph that looked like this, and that was 4 pi. And this was 2 pi. Okay, so that's definitely a sine graph. And Sine graph, since you're starting in the middle and then going up, and it's definitely with a positive a since it starts at 0 and then climbs up. The period is 4 pi. And so you go 2 pi over b is equal to 4 pi. And solving for b, you would get multiply by b, divide by 4 pi. Your pi's will cancel, and 2 goes into 4 twice. So your b is 1/2, and so it's just a y equals sine of 1/2 x. It wasn't a shift up or down or anything, and so, all right. Is the C in the middle for cotangent to when you graph it? Yes, absolutely. Because you're gonna, when you graph cotangent, I always graph tangent to get to do it first. All right, 21 on the quiz. All right, the amplitude of a sound wave produced by middle C is 2.3, and the frequency is 134. Determine the sinusoidal function that describes this sound. So if the frequency is 134, then that means that the period is 1/134. Frequency and period are reciprocals. And you're going to use a sine graph since it's a sound wave, right? And so at time equals 0, there's no sound, and then you start playing, and then it goes like that. So you're going to use a sine graph, positive a value, and you need to know the b value. So the period is equal to 2 pi over b. So 2 pi over b is equal to 1/134. And so if I multiply both sides by, well, here we can do a cross multiply on this guy. So that's a b times 1 equals a 2 pi times 134. So your b value is a 268 pi. And so your equation is y equals 2.3 times sine of 268 pi times t. All right. That was 21 on the quiz. Can you also do 20 from the quiz? So we got y equals 1/2 secant of x plus 1. So I'm going to graph cosine first because that's the reciprocal. Right, so and your a is 1/2, your b is 1, c is 0, and then d is 1. The period of cosine is 2 pi over b. So then the increment length will be 2 pi over 4, which is pi over 2. We got to shift up one, okay. So your c is 0, and increment length pi over 2. So pi over 2, and then that would be pi, 3 pi over 2, and then 2 pi. Your y-axis is going to go when x is 0. And we need a 1/2, but then we're going to go up to, okay, so let's go, let's say that's 2, that would be 1, 1/2, that's going to be 3/2, and then, boop, -1/2. Okay. And, -1. Okay, so I'm going to graph cosine first, and it starts up high and then comes down to 0 and then down to -1/2 and back up to 0 and then to +1/2. So that's cosine. And then I'll graph secant now, and secant is the reciprocal of cosine. So anywhere where there's a 0 will now be an asymptote. So there and here. The other points are going to match, and then it just turns like this half of a hill of cosine into half of a valley and up towards the asymptote. And I should have dotted that because I'm not done. I still have to do a shift. Like that. And then this point will be the same, but it turns it into this valley. It turns into a hill, and then this point will be the same, and then it will shift up like that. All right, and then after all of that, I'm going to shift it up 1 unit. So that means 1/2 will go to 3/2, and then it'll go up like that. Your asymptote stays the same when it gets shifted up. So does this one. Asymptote stays the same. And then -1/2 plus 1 will be a +1/2, so it'll be here and going down like that. And then this 1/2 went up to 3/2 right there, and then it's curving up towards there. So the red is my final graph of that guy. Okay. So that was 20 from the quiz, 17 from the quiz. All right, inverse cosine of x plus 1. All right, so your regular cosine, inverse cosine, is 1 to -1, and from 0 to, I did not give myself enough room. Let's do this again. Let's go doot and doot. Okay, there we go. Okay, so we've got -1 to 1, and then let's say that's pi over 2, and that's pi. So here's regular inverse cosine is at 0 and 0 pi over 2, and then -1 pi, and it curves like this. Something like that. It's deformed a little bit, but whatever. So there's regular inverse cosine, and then we're going to shift it all up 1 unit. So I'll do a different color. Let's do that color. Okay. So if I'm shifting it up 1, this would be like 1, since pi over 2 is about 1.5. Yeah, all right. And then pi over 2 plus 1 would be right about there. And then pi plus 1 would be right there. And so my graph would be here, here, and here. Like that. So I told my students they needed to give me these exact values, not decimals or anything like that. You either change your values on your y-axis to be like the exact pi over 2 plus 1 and pi plus 1, or you could label it like this point right here is -1 comma pi plus 1. this point right here is 1, 1, and then that point right there is 0, pi over 2 plus 1. Anyway, you need exact. You should not be giving decimals or not labeling those exact values. Okay, that was 17 from the quiz. Can you go over how to rewrite things as an algebraic expression? 14 on the quiz. Yes. So sine of inverse tangent of z over 3. Okay, so I'm going to let this guy be my theta. So I'm going to draw my triangle in quadrant 1. And tangent is y over x. So that means my x is 3 and my y is z. And this is my theta. And so to find r, or your hypotenuse, r squared is x squared plus y squared. So it ends up being 3 squared plus z squared. So r squared is equal to 9 plus z squared, where r is equal to plus or minus the square root of 9 plus z squared. But r is the hypotenuse, so it truly is the distance from the origin to this point, and so it is always positive. Your hypotenuse is the square root of 9 plus z squared. And then we want sine of this angle. And so sine of theta will be y over r, or z, over the square root of 9 plus z squared. And then you want to rationalize that by multiplying top and bottom by a square root of 9 plus z squared, so that we get rid of the radical. And so your answer will end up being z times the square root of 9 plus z squared all over 9 plus z squared. That is simplified. You can't, that z does not go into the z squared in the bottom because it's z squared plus 9. So that's fully simplified. Don't go crossing out that z and losing points for that. Okay, that was 14 on the quiz. Okay, which trig functions don't have amplitudes? All right, amplitude truly is the maximum value minus the minimum value divided by 2. And so sine goes like this. And it keeps on going, but it truly has a maximum and a minimum. And cosine goes like this. But then it, keeps on going, but it has a max and a min. The rest of them, so these are the only two that have amplitudes. Because all of the rest of the graphs, tangent looks like this, going on forever and ever and ever and ever, right? And cotangent does the same thing, where if I'm graphing just the normal period, it looks like that. But it's going on forever and ever and ever and ever. And secant is the reciprocal of cosine, and so it boop, 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 it looks like that and like that. But they go on forever and ever and ever in the positive y direction and the negative y direction. This one goes and going up and going down like that. Anyway, they go on forever and ever in the positive y direction and the negative y direction. And so all 4 of the other guys, there is no amplitude because there is no max And there is no min to be able to find the amplitude. Sine and cosine are the only two trig functions that have an amplitude. All right. We are on page 198, page 33. Finding the zeros, okay. Page 198, number 33, wants you to find the zeros and the local max and min, okay, for f of x equals 3 times cosine of 1/3 x minus pi over 6. Okay, so finding zeros, that's when y equals 0. And so you'll set your y, or f of x, equal to 0, and then solve for x. All right, so dividing both sides by 3, 0 divided by 3, so you still have cosine of 1/3 x minus pi over 6. All right, so this little box right here is my theta, right? That's my angle. And so what I'm trying to answer is cosine of theta of an angle is equal to 0 when? Well, when theta is pi over 2 and 3 pi over 2, or just two of them, right? I think your book is probably going to give you all of the answers. We're going to just ask you for 2 of them. So, so that's what you do, is you set this theta, 1/3 x minus pi over 6, equal to the 2 zeros I just found, when cosine of some angle is equal to 0. 3 pi over 2. All right, so I need to add pi over 6 to both sides on this one, which will give you a 1/3 x equals, what would that be, times 3 times 3. So a 3 pi over 6 plus pi over 6 is a 4 pi over 6. And then multiplying both sides by 3 would give you a 12 pi over 6, which ends up giving you a 2 pi. And then do the same thing here, adding pi over 6. You'll have a 1/3 x is 9 pi over 6 plus 1 pi over 6 is 10 pi over 6. Multiplying both sides by 3 would give you a 30 pi over 6, which is a 5 pi. Your book gave all of the zeros, so what did they say? 2 plus 3k times pi. Yeah, 2 pi and 5. We're going to just ask you for 2, so this is good enough. Set it equal to 0. And then do that. That'll be good. All right. What's next? Page 206, number 19. Y equals 4 times cotangent of 3x minus 3 pi over 2, and then minus 1. And what do they want you to find? Determine the period, phase shift, vertical shift, and the equations for the vertical asymptote for 2 of them. Okay, so this is equal to 4 times cotangent of 3 times x minus 3 pi over 2 divided by 3 would be a pi over 2, and then a minus 1. which means that your A is 4, B is 3, C is a positive pi over 2, and then D is negative 1, and they want the period. Okay, so your period for cotangent and tangent is pi over B, so that means pi over 3, period. Phase shift, your C value is a positive pi over 2, so pi over 2 to the right is your phase shift. Vertical shift, your D is negative 1, so that means you're moving down 1 unit. And then the equations for the vertical asymptotes. All right, so your vertical asymptotes are happen when your cotangent is undefined. Now, for zeros, finding the zeros, your D value and your A value, like they make a difference. For the asymptotes, it's just like a straight line. So when you're shifting it up or down, it's not affected. So your vertical asymptotes are when cotangent of blah blah of your angle is undefined. All right, and it's just, so let's talk about your parent graph of cotangent of theta is undefined. Well, that's when x over y is undefined, and so that means when y is equal to 0. And y is 0, whoops, y is 0 here when theta is 0 and pi, and 2 pi, and 3 pi, right? So when theta is 0 or pi, those are the two I'll say. Okay, the only difference though is that you don't just have theta, right? Your angle this time, this little guy right here, is this guy right here. We call it the argument, or the angle, right? That is changing where they're undefined, and so there's a 3x minus 3 pi over 2 there. So you're going to set that guy equal to where cotangent normally has asymptotes. So you'll have 3x minus 3 pi over 2 is equal to 0. And then also 3x minus 3 pi over 2 is equal to pi. And so adding 3 pi over 2 to both sides and dividing by 3, x would be pi over 2 will be one asymptote. And then what? 2 pi over 2 plus 3 pi over 2 would be a 5 pi over 2. And then dividing both sides by 3 will give you a 5 pi over 6. 19. Yep. Those will be your two of the vertical asymptotes. There's more than just those guys, but those would be the ones that I would give. I always just go for the first revolution around the circle. All right. That was 206, 19. Okay. 197, number 28. For finding the zeros. Okay. So none of the other stuff I'm going to assume. Just want to find the zeros. Of y equals sine of 1/4 x minus pi. All right, so finding the zeros is when this guy is 0. I really would rather do 26. It's more interesting, but whatever. All right, so you got that. So what you're looking for is, this is your angle, this is your theta, right? That's your theta. So when is sine of theta equal to 0? Well, here and here. So when theta equals 0 and pi, your sine will be 0. So you're going to just set that angle equal to 0, and then also set that angle equal to pi, and then we'll solve for x. So multiplying both sides by 4, so 4 times 0 is 0, and then adding pi, you would get x equals pi. On this one, multiplying both sides by 4 will give you x minus pi equals 4 pi, and then adding pi will give you 5 pi. So pi and 5 pi would be the two zeros I would give. All right. Number 7 on the quiz. Why wouldn't the point be 1 comma pi over 2? Number 7 on the quiz. Keyboard's not working. Are we talking about number 7 on the quiz? I don't think it's supposed to be number 7. So 17 on the quiz. Okay. So, for number 7 on the quiz, why wouldn't the points be for 17 on the quiz? They were. I already did number 17 on the quiz, but those were the points. Did I not write that? I'm pretty sure I did. 1 comma 1 plus pi. 1. I wrote something different. Let me look real quick. Go back to it. I don't know how far back was that. Oh, the very last one is the one you've got a problem with. Okay, so I wrote -1 comma pi plus 1. Yep. 0 comma pi over 2. Oh, it's plus 1 because you're shifting the whole graph. So the regular, so if it was y equals inverse cosine of x, your points are 1 comma 0, 0 comma pi over 2, and -1 comma pi. There's obviously more points than that, but those are the 3 like anchor points I use. And so you're doing your y is equal to this y value that I just wrote, but then plus 1. And so when you do y equals inverse cosine of x plus 1, then you'll have a 1 comma 0 plus 1. I'm adding 1 to all of my y values. 0 comma pi over 2 plus 1, and -1 comma pi plus 1. You're just adding 1 to all of your y values. Is that what I wrote? Yep. Yes. Okay. Okay. So hopefully that makes sense. Let me go back to. Okay. All right, let me scroll back up. Okay. Can the inverse trig functions have amplitudes though? Because inverse sine has a max and a min. We don't ever talk about the amplitude of an inverse sine. We talk about amplitude when we're talking about, it definitely does have a max and a min. You're absolutely right, Nolan. But when we talk about amplitude, we're talking about like a periodic function. And inverse sine, and the inverses aren't periodic. So, can you find the domain and ranges of inverse functions? Can you find me a problem? And I will. Do I have to memorize what the inverse trig functions look like? Yes, Thomas, absolutely. Either that or, I mean, I don't know who you have as a teacher. You can see if they'll let you bring a Sharpie and draw it out or whatever, but Other than that, yeah, you've got to definitely know what the parent graphs look like, including how they curve and stuff. But yeah. All right, well, I guess maybe you want me to do all of the domain and ranges for all the inverse trig functions. So let's go with y equals inverse sine of x. This graph looks like it goes from -1 to +1, and from negative pi over 2 to positive pi over 2, and it looks like this. All right, so there's inverse sine, right? So your domain is -1 to 1, and your range is from negative pi over 2 to positive pi over 2. Inverse cosine looks like let's say that's pi, and then this is pi over 2. You have there, there, and there, and it curves like this. All right, so the domain are the x values, and so from -1 to 1, and the range are the y values, 0 to pi. And then I need to go to a different slide for the other guys. For tangent, and go back, capital T. All right. For y equals inverse tangent of x, that guy looks like you got an asymptote at y equals pi over 2 and an asymptote at y equals negative pi over 2, and it goes like to pause. I don't know what happened. Are you guys there? Is it still recording? Hopefully. It says it's still being recorded. Okay. I don't know what happened. All of a sudden it just said connection lost. I looked at my router. I still have internet connection, so I don't know what the heck happened, but all of a sudden everything went out. I think it's an Adobe Connect thing, but okay. Well, crap. Is everything still there? And the chat completely went away. Okay, well, all right. So I'll finish this, but then I don't know what any other questions you guys have because all of the chat window went bye-bye. It still has a red button, so it still says it's a recording. I wonder if it's not going to show the whole thing. Hopefully. Okay, so here's a graph of inverse tangent. And so your domain is all real numbers because your x values are going both directions, and your range are the y values from negative pi over 2, but those are asymptotes, right? So strictly less than, not the or equal to, and a positive pi over 2. And then inverse cotangent looks like you got an asymptote at y equals 0. You got an asymptote at y equals pi. And it goes whoop and whoop like that. And so your domain is all real numbers, and your range is from 0 to pi. And then we're not going to ask you. Do we ask you for domain and range of cosecant and secant? I don't think so. But I'm not going to do it. Don't worry about it. Okay. 221, number 28. I hope that this recorded the whole time. I hope it didn't get messed up. Oh my gosh. That really sucked. 220. Okay, number 28. Page 221, number 28 says arc cosine of sine of 4 pi over 3. All right. So we're going to start on the inside here. Sine of 4 pi over 3. 4 pi over 3 is this guy here. That is a tall one. So that is a rad 3 over 2 on this side, a 1/2 on this side. Quadrant 3 though, so both of them are negative, right? So this means it's arc cosine of negative rad 3 over 2. All right, now arc cosine is a rainbow, meaning that you're restricted between 0 and pi in giving answers. So you can't just give me a quadrant 3 angle. Instead, you're going to give me this one in quadrant 2, since it's negative. Cosine's negative in quadrant 2. And cosine means that it would be, this would be the x value is a negative rad 3 over 2, the y value is a 1/2, and then a 1. And that triangle is the short one. It's a shorty triangle, so 30 degrees, right, which is pi over 6. And in quadrant 2, that is a 5 pi over 6. All right, what other questions do you have? Wow. It's crazy. Could you go over when to use rainbows and bananas? And I don't really understand that stuff. It's that whole thing of, it's the inverse functions. So inverse trig functions. They wanted them to be functions. And so if you were here for the Sharpie days, that's the reason why we traced over only a portion of the graph, so that you would end up getting a function when you do the inverse trig function. And so we always wrote them in sine, cosine, tangent, and then their reciprocals, cosecant, secant, and cotangent. And so just a way to help you remember, BRB, because burr, it's cold, be right back, because burr, it's cold, helps you remember if it's a restriction to the banana, means that it's restricted here. how it kind of looks like a banana? Well, that means it's restricted from pi over 2 to negative pi over 2. So if you were to write, let's go, so it's your range, right? Your y value is between pi over 2 and negative pi over 2 if you have a banana, and then a rainbow is the restriction from, see how it kind of looks like a rainbow, from 0 to pi. So the range is from 0 to pi if it's a rainbow. That's all that was talking about, is that is the range values, right? That's how you know how it's restricted. Okay. Inverse trig functions, right? I just did it on this problem right here, arc cosine. I used rainbow, right? If it had been arc sine, I would have used a banana. Or if they talk about range and stuff of inverse trig functions. It's for the inverse trig functions. Okay. Arc sine and inverse sine are the same thing, yes. So arc sine is the same thing as inverse sine. Two different ways of writing it, but they mean the exact same thing. Okay. Page 238, number 27. Oh my God, did it go out again? There we go. A weight is suspended from a spring and it's set into oscillating motion by pulling it to a point below 6.4 centimeters below its resting position and then releasing it. It takes 2 seconds to complete one cycle. And determine an equation describing the position of the weight at time t seconds, letting 0 represent its rest position. All right, so it's been pulled below before it starts its motion, and so you're going to use a negative cosine. And your period here is 2, and so 2 pi over b is equal to 2, and so your b is equal to 2 pi over 2, which means your b is pi. And so it'll be a y equals negative 6.4 cosine of pi times t. So I already did a spring one where it was compressed up, so I used a positive cosine. This one was pulled down first and then released. How would you do, for instance, an inverse cosine and a positive sine? An inverse cosine and a positive sine on the same graph. We won't ask you to do that. If it asks for 2 vertical asymptotes for cosine or sine, would the answer just be none? Yes, we would never ask you for 2 vertical asymptotes on cosine or sine because there aren't any vertical asymptotes. Arc sine and inverse sine, yes, they are the same thing. Okay. We would not have you do inverse sine plus cosine of 2x. Not going to happen. Not going to ask you that. It'll be a periodic graph added to another periodic graph, and inverse sine is not periodic, so that question won't be asked, Leah. Page 239. Oh, but then you said never mind. Page 236, number 6. Don't worry about the optic air to water thing. You don't need to know that part. All right. Anything else? It's 239 over 14. Okay, I already did that one. I think I got time for like one more and then we'll call it quits. And fingers crossed it kept recording through the loss of connection. All right. If I have y equals cosine of 2x plus sine of x, we're going to give you the two graphs and then you're going to add them together. So let's see, this guy would be a period. The period is pi and this one is 2 pi. Okay, so bump, bump, bump. Okay, so if I say that's 2 pi and pi, your sine graph, sine graph will be here, 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 here. Something like that. And then the cosine graph will be the period for cosine of 2x is pi. So that means I need these guys. Womp, 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 womp. All right, so if that's pi over 2, then this is pi over 4. And the graph of this guy, you're going to start up here, and then pi over 4, you'll be here, and then down here, and then there, and then there. There's one period, but then what you got to do is continue this. So it'll come down here, and then there, and then there, and then there. All right, so now what you're going to do is at each of these x values, you are going to add up the y values. All right, so at x equals 0, I've got a 0 plus a 1. 0 plus 1 will give you 1. At pi over 4, I've got 0 plus whatever this y value is on sine. At pi over 2, I've got negative 1 plus 1, so it'll be a 0. At, that must be 3 pi over 4, I've got a 0 plus this guy. And then on this one, it's here. I'm adding up the y values on each of these guys. That would be there. Negative 1 plus negative 1 will bring you down to negative 2. This one will be here, and then that one will be there. And then you just connect all the little red points. So it looks something like that. Yeah, you just, for each of the x values, go and look. Got a y value plus a y value. When you add those y values together, what's your new y value? Nope, I already said the optics one won't be on there. I'm going to apply the x values divided by b and the y values divided by an amplitude strategy. When do you apply the x values divided by b and y values divided by, I don't know what you're talking about. At pi over 4, at pi over 4, I had cosine was at 0, but sine was at a higher value, so I don't think so. Oh, right before it, maybe? Okay. I don't really care about all the in-betweens, but you're probably right. It probably did kind of go up a little bit before and then come down to that, but not a big deal. Okay. I'm going to stop this recording and hopefully it saved the whole thing. Fingers crossed. Good luck.